All right. So yesterday we did equations with variables on both sides. Today we're going to do inequalities with variables on both sides. And actually, what's going on is these equations will be almost exactly the same as you did yesterday. And because I just want to show you that's the same steps, except for when you multiply or divide both sides by a negative, the inequality sign will flip. So we have this inequality. Okay. So you draw your line. I always like to make my variable to get to the left side. So I'm going to subtract 4x from both sides. Okay, so now you have negative 2x plus 3 is less than negative 5. So now we subtract 3 from both sides. So now you have negative 2x is greater than negative 8. So we're going to divide both sides by negative 2. So that means my inequality sign will become a greater than sign. So negative 8 divided by negative 2 is a positive 4. And if I would graph that, 0, 1, 2, 3, 4, 5, an open circle will go above the 4 and it'll go to the right. Okay, and you can check it the same way. So you rewrite it. So I'm saying x is greater than 4, so I would plug in, well, it wouldn't check it, like you couldn't check it as well. I would just leave it like that. Because if you would plug it in, you get both sides that's equal each other, and that wouldn't work. But technically, this would be the answer because anything greater than 4. So if you would plug in, like, let's say 5 to the equation, then that would work. But it's just a little bit harder to check the inequality because of the signs. All right, so now you pause the video and try one. All right, so same idea. Draw my line. I'm going to subtract 7x from both sides. I get negative 3x plus 4 is greater than negative 5. Okay, so I'm going to subtract 4 from both sides. You get negative 3x is greater than negative 9. So then you divide it by negative 3 to both sides. You get x is less than positive 3 because your sign had a flip since you divide both sides by a negative. Okay, now onto the back where we did these yesterday, and I taught you multiple ways to do it, where you can just subtract the x divide by 9 and x divide by 3 and subtract the fractions. Or as I like to do it, I like to multiply everything by 9. But I was looking around the room yesterday, and half of you were doing the one way, half of you were doing the other way. Again, that is perfectly fine because either way is correct. There's no better way. It's whatever way you would like to do it. I prefer this way. So I'm going to do 9 times x divided by 3 minus 3 times 9 is greater than or equal to x divided by 9 times 9 plus 3 times 9. So we simplify this, it would be 3x minus 27 is greater than or equal to x plus 27. So now we just solve it. I'll subtract x from both sides. I get 2x minus 27 is greater than 27. So you add 27 to both sides. So now you have 2x is greater than or equal to 54. So you divide by 2, and you get x is greater than or equal to 27. So then if you did your number line, 26, 27, 28, it would be a closed circle on top, and it would go to the right. Okay. Now you pause the video and try one. So again, I'm going to multiply it by 8. But if you want to subtract it, that's perfectly fine. Gonna run out of room. I'm just say that 72 because 9 times 8 is 72. So that'd be 2x minus 32 is less than or equal to x plus 72. So now I subtract x from both sides. So now I have x minus 32 is less than or equal to 72. So then I add it. Pin. You get x is less than or equal to 104. And so the answer would be C. Alright guys, so this was basically literally the same idea that we just did yesterday, but you just got to pay attention to when you multiply or divide both sides by a negative, you have to flip the sign or flip the inequality sign.